Okay, let's start with d6. Okay, for the first one, the derivative of y prime is a notation for derivative. You can also write dy over dx instead of y prime here. So that if you take the derivative of this, you would just use power rule. So the 7 comes down here. And then you reduce this by 1. So it's just x to the 6th. Okay, and then for the second one, whenever you see this, you want to always rewrite it. It's always helpful to rewrite it, so you can use power rule. Rewrite it as a negative exponent, like this. And then from here, you can use power rule. So the negative 5 comes down here. And then you reduce this negative 5 by 1, so it's negative 6. So then this whole thing is just negative 5 over x6. Okay, for this one, first we write this as a negative exponent. Okay, now you take the derivative using power rule. So the 7 comes down here, or the negative 7 comes down here, and then you have 3 times negative 7. So you have negative 21 down here. And then x to the, and then it'll be negative 7 minus 1. You reduce this by 1, so it becomes negative 8. And then you can rewrite this again, get rid of the negative exponent, so it becomes negative 21 over x to the 8. Let me rewrite that. Negative 21 over x to the 8. Okay. For this one, you want to bring out the power. So it's the same as y equals x to the 1/5. Okay, now we can use power rule that we see the power. So y prime is equal to, so you bring the 1/5 down, then x to the, and then it's 1/5 minus 1, right? You reduce the 1/5 by 1. 1/5 minus 1 is negative 4/5. And you want to get rid of the negative exponent. So it's y prime is equal to 1 over 5 times x to the 4/5. Okay, and then for this one, so this one, make sure you're paying attention because they put it in terms of t here. So y prime in this case would be, if you use power rule, the 2 comes down here, so negative 2 times 2 is negative 4, and then this 2 is reduced by 1, so it becomes just 1, so it's negative 4t to the 1, and then plus, so this thing is 3t, so whenever you have anything in the form of derivative of, let's say, derivative of ddx of ax, where a is a constant, or actually I'll write it as cx, where c is a constant, this is just equal to c. Now you can use power rule to show this, because you can think of this as a 1 here. So the 1 is multiplied to the c, the 1 is reduced by 1, so it becomes cx to the 0, which is just equal to c. So that's why this works. So here we just know that this is equal to 3 because of that. So this is 3. And then the derivative of a constant, any constant, is always 0. And you can show this the same way. Yeah, you can show this the same way because this is cx0. And then if you use power rule, then it's just equal to 0 because you're multiplying this by 0. Yeah, and then yeah, that's all you have to do for this. And then the notation, if you want to use instead of y prime, if you want to use the other notation, it would be dy over dt here, since we're in terms of t and not x. But like I said, you can choose whichever one you choose is fine. Okay, here rewrite this again. If we rewrite this, this is the same as 5 over 2 times x negative 2. Okay, and then now use power rule. So the negative 2 comes down here. Negative 2 times 5 over 2 is negative 5. And then you reduce this by 1. Negative 2 minus 1, negative 3. Now rewrite this again. Okay, and that's all for these 6. And for this one, so slope of the tangent line questions, you'll see these a lot, but you'll get used to it if you do them multiple times. For this one, the first step I always do is to take the derivative. The goal is, so the goal of doing these and what you want to do is you have to get the equation of the tangent line. So that any equation of the line will be like this, or you can use point slope form if you're more comfortable with that. But you just want to get the slope, and that comes from taking the derivative and evaluating at this point. And then you want to use this point and your slope to get your equation. If you have a slope and a point, you can find an equation of a line. So that's what we're gonna do. So first step, find the derivative. So y prime is equal to power rule. 4 comes down here, so 4, and then reduces by 1, so it's 3. And then here 2 comes down here, so it's 3 times 2 is 6. And then x, you reduce 2 by 1, so it's just 1. And then this is 0. So this is your derivative. Now you're evaluating this at 1 comma 0. There's a notation people sometimes use. You don't really have to use it, but I kind of like it. It's just you write dy over dx, you put a line, and then to show you're evaluating it at 1 comma 0, you just put the line and then 1 comma 0, and then now you just uh, plug it in. In this case, it doesn't really matter about the 0. This whole thing is in terms of x on this side, so we just have to plug in 1 for everything. So 4 times 1 cubed minus 6 times 1, so it's 4 minus 6, which is negative 2. Okay, so our slope is negative 2. So I always like to write like this. Our slope is negative 2. Our point is 1 comma 0. And this should be familiar from algebra. Just if you have a slope and a point, make an equation. The way I like to do it is to use slope-intercept form. So the way I do it is just fill in the slope-intercept form. So it's 0 equals negative 2 times x. X is 1 here. Plus b. And then I just solve for b. So b here is 2. So then the equation of the tangent line would just be y equals negative 2x plus 2. And that's all for this one. Let's see what else. Oh, oops. Alright, for this one. This is a good question. They test your conceptual understanding. They do this a lot on the AP exam. Okay. So at which value of x is f continuous but not differentiable? So when I think of continuous not differentiable, I'm thinking there's a cusp. So when there's a cusp, it means there's a sharp point. Something like this is a sharp point, this is a sharp point, this is a sharp point, something like that is a sharp point. That's what they're looking for. Okay, so immediately after reading that, this is continuous, right? If you were to draw this without lifting your pencil off your paper or whatever, you'd be able to do that. You'd be able to draw this without lifting your pencil, okay? But for example here, you can't draw this without lifting your pencil. That's just one way you can think of it. So this is a cusp because it's a sharp point. I always think of the absolute value, this thing here, for an example of something that's continuous but not differentiable, because it's a sharp point. But in this case, this is continuous, not differentiable, and this is at point A. So yeah, your answer would be A. And if I were to just look at the other choices and see like what possible traps do they have, this one, so it's defined at B, but the problem is that you can't draw this without lifting your pencil off the paper because there's a point here. So you'd have to go like this, then put a point and then go like this, right? You'd have to lift your pencil off the paper to do that. Doesn't work. This is not continuous. Point C, this is continuous and differentiable because it's smooth and continuous. Point D, this is a jump discontinuity. It's not continuous at all. And then point E, it's smooth and continuous and differentiable, so it's not these conditions, so the answer is A. Okay, and then the last one, so you just want to use the definition of the derivative. So it's good to have this memorized. I'm not going to require you to, but eventually you will have to memorize this. So it's f of x plus h minus f of x all over h, and its limit as h approaches 0. Okay, so now all you do for these is they're going to give you a function, and you just rewrite this function as f of x plus h. If you were to do that, you'd get 3 times x plus h squared plus 2 times x plus h plus 7. Okay, so now let's write that in here. So f of x plus h would be 3 times x plus h squared plus 2 times x plus h plus 7. And now you do minus f of x. So minus this whole thing. This whole thing is, I'll just distribute the negative sign to start off because we'll have to anyway. So minus f of x. Actually, I'll just leave it for now. Okay. So minus f of x. F of x is 3x squared plus 2x plus 7. Okay. All over h. Yeah, these problems, doing it this method, it's kind of annoying. There's a lot of steps involved, a bunch of algebra. It's just annoying to do this. That's why power rule and all those other methods exist. We'll get to the other methods. Um, but yeah, they'll require you to do this. That's the only reason why I have to show you. Okay, limit as h goes to 0. And then you're just gonna have to expand this and try and simplify it. The goal is that you get rid of this h here so everything else can simplify nicely and you can use this limit. So if you were to expand this, I'll do it all in one step. This is 3x squared plus 6xh plus 3x squared, 3h squared, and then plus, let's see, 2 times, okay, 2x plus 2h plus 7, and then let's distribute this, minus 3x squared minus 2x minus 7 all over h. Okay, okay, now let's just simplify the top thing. Let's see, okay, so this and this cancel. Let's see what else cancels. This and this cancels. This and this cancels. So we're just left with 6xh plus 3h squared plus 2h all over h. And this is convenient because now we can cancel out the h's by dividing by the h. So limit as h goes to 0, and then this becomes 6x plus 3h plus 2, and now just evaluate this at 0, and then this is 3 times 0, so it's just 0. So you're just left with 6x plus 2. Okay, so yeah, it did require a bunch of steps, but it's necessary to do it. And yeah, power rule is way faster on this. I can do this in like 2 seconds with power rule. You just use power rule here, and it's just y prime is equal to 6x plus 2. You can do that in like 1 second like that. You don't have to go through this whole thing unless you're using definition of the derivative, but they'll require you to do it. So yeah, these are the practice problems. If you have any questions, let me know. Okay, thanks.